Okay, we'll go ahead and get started. So today, we're going to go through like a bunch of coding techniques, resources, and just info that will be potentially helpful in the final project. That's going to be kind of the main focus. If we have time, I might talk some about generally documentation in games, but that's kind of the optional, before I started this video, the optional material I was referring to in the sense that like it's not on a quiz or something like that. It's more just like a for your information thing. And I know some of you are taking game design and probably already know more about those documents just from that class. But so we'll see if we have time to cover that stuff too, but I think that we probably will. As far as challenge 3 goes, it'll probably be a minute before I get those graded just because it's a pretty complex assignment. It takes a while to grade, but you should definitely have it back at the absolute latest by the like Sunday after Thanksgiving because I want to make sure you have at least a week with your feedback before the final project. If for some reason that does not happen, I would probably actually move the final project back so that you do get a week because like I feel like it's not fair to give you less than a week with knowing what you need to look at and stuff like that. But I'm pretty sure it's going to be done before then, so I'm not going out of town or anything like that next week. Let's see. So it's kind of the main things we're covering today. Next week, remember, we don't meet for class because of Thanksgiving week. So, and I'll talk about the week after that, but we actually won't be physically meeting for class that week either. So, I guess the first thing I want to talk about is just we did the space shooter demo a minute ago. If you're watching the video, this is based on a old tutorial from the old version of the class that demonstrates a couple things in particular that I want to show off. Coroutines and arrays, which we looked at. I showed the game, basically how it works in class, and then I talked a little bit about those ideas. I'm going to talk about them again on these slides because they show up on the slides. But if you want an example of them in action, I would download that project/build. And I need to update the build on web courses because I think there's a issue with it not being there in just the project. But the project is where the code is. So if you want to see the code for what it's doing, the entire project is there. You can look through all the code for it. The particular script you want to look at, if you want to look at what we were looking at in class, is the game controller script. That's where the two concepts I want to talk about, arrays and coroutines, come from. And again, I'll talk about them on these slides too, but if you want to see it in action. The game itself is like a Galaga game. So if you want kind of an idea of what type of game this is. You also maybe don't even need the build because you could probably find somebody playing through it on YouTube. You can probably even find the old tutorial on YouTube if you're really hunt for it a little bit. It's probably up there. So let's see. So what I'm going to do basically today in the first chunk of the lecture is go through some resources for the final project. There's also a web courses page that covers all this and has all these links. So all the links that are in the PowerPoint slides that obviously are just in a video right now and you can't click on are on a page on web courses that you can click on. So these are all good further learning resources too. A lot of times I have students ask me over the course of this class like, hey, where's somewhere I can go to learn some more about Unity? This is typically my first set of suggestions, is the stuff that's on that page, basically. In fact, a lot of times I recommend these same resources right at the beginning of game production because I don't know for sure that everybody has taken this class with me. Most people do, but I do it just to be sure everybody still has it as well, just access to it. So I guess I'm going to go through. I'm going to show you the links, but also talk about why I think each one is useful or what you could use it for on the final project. But the first thing I'll start with is just the Unity Learn tutorials. So these are a bunch of other tutorials that are essentially very similar to Ruby's. They're full games. You can start from scratch. You can work through them and build up a full game. Obviously, for the final project, you need to work with Ruby's. So you wouldn't want to go and do one of these and try to turn that in as the final project. But Space Shooter used to be one of those. Rollerball is one of those. There's a bunch of other ones. They introduce stuff that you may be able to then bring into Ruby's and then basically use in Ruby's instead. Usually the way they organize this is projects and topics. So projects are usually step-by-step tutorials like the Rollerball and Ruby's. Topics tend to be a little bit more advanced. They don't always have a video, but sometimes they do. And I guess the only other thing to keep in mind, you've already seen this this semester because it's something you probably ran into problems with at some point. Or on my notes page, I sometimes have to tell you specifically hey, something they do in this tutorial doesn't work this way anymore. You have to do it like this now. A very common thing is that these tutorials are made with an older version of Unity and need some sort of update to get working in the modern versions. One of the reasons Space Shooter got phased out, for example, is it was so old and had like a 20-plus page long update document on how to get it working in the modern version of Unity. And I was like, okay, at this point, we should probably just pick one that's actually newer. Because like, if we have to spend that much time updating it, it's a great tutorial, but yeah, at this point, like there's so many updates you have to make, it's ridiculous. Whereas Ruby is, you know, it's not as bad. There are some things that don't work the way they explain it on the tutorial page, but that being said, it's not nearly as much as like Space Shooter. We have to change almost everything. But they do sometimes have those available, so be aware if you're using an old one and it seems pretty out of date and you're like, okay, this just doesn't seem to be working, check and see if they posted an update document that explains, like, here's what you need to change to get this working now. The next thing I usually go to is various YouTubers who I think do good YouTube or Unity tutorials. There's a ton of people on YouTube who do them. But there are some in particular who I think I personally would recommend as like a teacher who's looked at a lot of their stuff and said, okay, this is something I felt comfortable giving my students, basically. I feel like it's good enough. Brackus is my #1 suggestion. It's like literally the first person I suggest to everybody when they say, where should I go? He's like one of the most popular Unity YouTubers. His videos are monetized typically, so keep in mind you'll have to watch like commercials, like in-video commercials like that they do on a lot of YouTube channels these days. But he tends to be very good at like high quality presentation and polish and stuff like that. You can tell he spent a lot of money on like cameras and mics and like stuff like other YouTubers do. Just keep in mind his tutorials are aimed at a huge variety of skill levels. So you may find something that is like way over your head at this point because it's just something that's like super advanced. But he also has stuff that's like incredibly entry level. So like completely, very similar to the like Rubies and Rollerball stuff. He's even done tutorials for Unity. Like there are a couple Unity tutorials that are actually him. So that's like a sign of how good he is. He's so good that the company was willing to hire him to do tutorials for him. Abel is the next person I typically suggest. The one drawback of Abel is that his videos are a bit on the older side, and they're not nearly as well polished as some of these other people. I don't think he was ever a professional YouTuber, and I don't know if he still even is putting out tutorials anymore. The benefit of his is that pretty much all of them are aimed at like complete beginners, and I think he does a really good job at clearly explaining like literally everything he's doing in all of his videos. So. Like he will walk you through every detail of the process. Sometimes that may even get frustrating because you may be like, okay, I already know this, but I know what a variable is and you're explaining to me what a variable is. But that being said, if you want someone who won't make any assumptions basically at all about what you know yet and will just go straight from the beginning, that's one of the reasons I like his. That's actually where I think the animation tutorial stuff came from one of his old videos. But I had put it together with the sound stuff and a bunch of other things, so I had to redo it basically so that it would work as a class assignment. Jimmy Vegas has a lot of videos too. So he has a very huge number of stuff on his channel, but it is like Abel where some of them are on the older side. I think he's still doing videos now, so I think he might still be putting stuff out. One of the things I think his videos are nice for is that they tend to be very straightforward and no frills. So you won't really see a lot of the stuff like in-video ads or things like that you would see on Brackus's channel. He also has some that are much shorter and they do a very single concept as opposed to trying to show 4 or 5 different things at once. I like that. That's just because that's similar to my personal style. I don't think it's the only way to do it. But I try to do the same thing with my demo videos. You'll notice they typically show just one thing, maybe 2 things, but I try not to show 10 different things in a demo video because then it makes it harder to drop it into different places or use it as a smaller nugget of information. And so I think his are good because of that. And then Saiku, most of his stuff focuses on visuals and graphics. I will say it's a little less polished, so it reminds me more of Abel on that front. But if you're in particular interested on visual stuff, creating new visuals for new game mechanics, things like that, he has a lot of visual focused things. So for mechanics, I don't think I would go to Saiku necessarily, but for animations, particle effects, any like stuff like that that you're trying to do, Saiku's channel is pretty good for those things. He has a lot of like good videos on that. Let's see. Other ones, these are just a few random tutorials that I feel like are well put together and could be useful for things that you might want to do on the final project. The Ray Wonderlic tutorials are a mixture of video lessons and then ones that are like Ruby's where it's just text and pictures. But they're pretty up to date. Like I remember checking these at least last spring and they were pretty up to date, so I don't think I've looked at it since then. I could check real quick and see if there's any like recent posts or things. But I think this is a good example of another like polished set of tutorials, like one of these people who's very obviously professional about doing this stuff and things like that. 2019, 2018, 2016, 2019. So it doesn't look like maybe he's done any in the last year or two. Oh, this is just one particular page too. This is just the Unity for beginners page. So there are other pages, is what I mean. Be aware some of them are also like a paid thing. So obviously, you know, don't pay for one. I wouldn't necessarily say pay for one unless you're like dying to get that or something. But you don't need to pay for anything for the final project. The tutorials point one is a specifically beginner's tutorial. It's mostly text and image based, and in general, they remind me a lot of the Jimmy Vegas tutorials. They're very straightforward, no frills. They don't have a bunch of fancy stuff, and so if you like that approach, if that's like your preference, I tend to like that kind of approach, then those can be good. The cat-like coding ones remind me a lot of the Saiku ones. They're very visual focused. It's stuff like shading, rendering, particles, animations, graphics. But it's a very similar set of tutorials to those types of things. There are a few, if you do some digging, there's a lot of stuff in there, and there might be a few things that are like mechanically focused, but they also have a ton of code examples. So one of the really nice ones there is that like there's lots of cut and pastable code on those tutorials that you can put into your project. So let's see. I think this is the odds and ends section. Yeah, these are just like random videos and tutorials on various concepts that, again, I think could be helpful on the final project. So they're just, they don't have like a, they're not like a bigger whole channel or something like that, or whole page. These are just like kind of a one specific thing type of thing. But they're just various things I found over the years that I felt like would be helpful, again, for things on the final project. So, oops, let me see if the odds and ends are here. I guess I lost the slide, but I can just go to them on web courses. This will also give me the opportunity to show you where all this stuff is on web courses. So, resources for the final project, this is the thing you're looking for. And the odds and ends down at the bottom, yeah, these are general, most of the stuff earlier is general resources. This is like, what if I'm looking for something more specific than that? Like, I really want to know how to do a coroutine, for example. I also linked the coroutines tutorial from Unity. It is an intermediate tutorial, so their intermediate tutorials assume you already know some stuff, which by this point you could probably be cool with. It's not my favorite coroutines tutorial, personally. Like, I don't think it's a great example. If I remember right, they use it for doing some stuff like moving boxes and things like that. I just like, there's many easier ways to do that than using a coroutine, so. I think the Space Shooter is a better example of how coroutines work personally, like, or what you would want one for. Spawning waves of enemies, yeah, that's a coroutine thing. A-star pathfinding, one thing you may run into with the A-star pathfinding tutorial is that the actual default package that you use for this, I think is now a paid package on the Unity Asset Store, but I know at least last spring in game production I was able to find the old free version, and the author has an old free version that they still have posted on the internet. You can still download and put in projects. They just have said, like, at this point, I'm not maintaining this one. I'm maintaining the one in the asset store that I'm getting paid for, basically. The old one still works, though. Like, people used it last spring in my game production class, and it was effective. But A-star pathfinding is a package, so it's like a external thing you download into your project that is used basically for handling pathfinding in a 2D game. So You want an enemy that can like chase the player or do dynamic movement, not just like moving left and right, up and down, things like that. Like you can move on a patrol or something. Or it can walk around walls, et cetera. That's what a pathfinding system is for. And A-Star tends to be the most popular 2D one that gets used in Unity. So definitely sucks that it has gone to a paid package. If you make a lot of 2D games, it might even be a package you want to consider getting, but just so you can have the most recent version. Raycasting is something you learn during Rubies, but I linked the mini Unity tutorial for how to do raycasting, just in case you want like more of a specific overview on just that and not the stuff you learned in the Jambi UI. And raycasting is used for a lot of stuff. So in general, I think I stressed that when we first learned that concept. When we talked about tutorial 3, and we went over, and I was like, let me talk about a bunch of things that are new in this that you've never seen before. One of them is raycasting, and yeah, raycasting gets used for tons of stuff in games, not just a dialogue thing. For example, raycasting is a common way to do like a guard that's searching for the player in a stealth system. Like they'll use a raycast to see, basically, and if that raycast hits the player, then the player gets spotted, that kind of thing. The countdown timer one is basically showing you how to do a simple countdown timer. So this one won't necessarily show you, if I remember right, how to link it into other mechanics. It just shows you how to display it on the screen and make it count down, not how to like end a game with it or something like that. But it's a good starting point for if you want to make a timer. And like at least one of my suggestions for significant gameplay mechanics on the final project is a time attack mode. So like this would be a great place to start if that's something you're trying to do. I think that's all the links and resources and stuff that I have up on web courses, but I also like to just talk about them a little bit and explain like what they're useful for and like what kind of stuff you can do with them and things like that. So, does anybody have any questions on those resources before I go on? Because then I'm going to go to next gameplay coding techniques. These are just also code concepts that could be helpful on the final project. That is the kind of thing typically you would want a pathfinding system for. You could set up something that's like a very, I'm not using the word dumb in a derogatory way, I'm using the word dumb in a it's not using AI way. Like a way that doesn't use AI to do that, you could probably set that up. It would run into problems though, because it wouldn't know how to do things like slow down or like speed up. It would literally just go, okay, the player's there, I'm going to move directly toward the player at a specific rate of speed and never stop. You know what I mean? So like getting it to do things like stopping or avoiding objects or anything else, you would probably need a pathfinding system. So that would maybe, you could probably use that for something like a projectile that perfectly tracks the player. That would probably be doable without AI, because you just have to tell it, here's the player's position and go toward that. But it is going to perfectly track the player if you do it that way. Like there's no way to get it to like, you know, the player can dodge behind an object or something, it is just going to chase them forever. So. Otherwise, you would definitely need to go to the pathfinding. You can get some like simple dodge mechanics. The aliens in that space shooter game I was showing off earlier before class started that are dodging to the left and right, they don't use AI to do that. They just use a randomized function that tells them whenever a certain thing comes up, dodge. And that's in, don't think it's in the game controller, but if you hunt around in that space shooter project, you can find the script that does that. I can't remember what it's called. I think it's enemy controller, because I think the asteroids use obstacle as their script, and I think enemy controller is for the aliens. And I think that's where the logic for the dodging is at. But so okay, some coding techniques and just concepts and stuff. This I think is also some stuff that's going to show up on the very final quiz. So keep in mind, like when you're doing the last quiz, this is what you would want to look at. This is just a quick review of some of the methods we've already seen, and then I'm going to talk about some other variations of these. So we know start, beginning of the game. We know update is every frame. We know on trigger enter is when you hit a trigger collider. So this is going to be like a bit more about those, some other variations of them, other built-in Unity functions that are useful. So awake versus start, this is a thing I've referenced a few times in class. I've explained, like, these are both functions that exist. We typically have been using start for most of the semester. I think you may have seen one or two things in Ruby that used awake instead. And you might have been wondering what's the difference between the two, because they both seem to happen right when the game begins, but they don't. Start is called during the first frame update after the game object is in the scene. So like, and you instantiate an object, and then once update happens once, like, or it happens during the first frame update. Like, once update happens once, you're also calling start for the first time, basically. Awake is called when the object is first enabled or instantiated. So either you use the set active thing to turn it on or off, or you didn't instantiate to instantiate it into the scene. And awake actually happens before start. So if you're actually like looking at, if you put both of them into a script and have code in both of them, what you will find is that awake is happening first, and then start is happening. And so in some complicated games or in some setups, there would be situations where you would want to use both, and you would want to use awake to initialize stuff and start to actually pass the information. A lot of times this might happen if you're like instantiating something and then sending info between scripts. That's a type of situation where you might be doing something like that. Awake is also really useful when you're instantiating prefabs during gameplay. So if you're spawning projectiles, if you're spawning waves of enemies, things like that. Or if you need to do something special to that prefab, like giving it a bonus damage effect or a spread shot effect or something like that, which would be things that for the final project would get you points. So awake would be a good way to set that up. Like when the object gets instantiated inside of awake, you do your thing that like checks to see did the player grab the spreadsheet shot pickup already, and if they did, now this is going to spawn 3 instead of 1. The various versions of update, I think we've talked about this a few times, so just as a reminder of kind of like there's 3 different versions of update, when they happen, and what you do in each one typically. Update is just the once per frame one. That's typically the one you want, that's where you put things you want to happen constantly. So if you want something to be constantly happening, it goes in update. Fixed update is for physics calculations, and typically it is for things you want to happen on a reliable timer, and specifically typically for physics things. I think that's why fixed update is usually used for physics. Late update is once per frame after update is finished. Typically, this is used for cameras. It also could potentially be used for other things like animations and stuff too. But late update is usually, like you might notice on a lot of the camera following scripts we've made in some of the earlier tutorials, they use late update. Oops. And then these are a bunch of other ordered functions. And I guess by ordered functions, I just mean these happen at certain times, like at specific points during gameplay. And knowing that they all exist and like, you know, that you have these options. There's tons of other ones. This is not an exhaustive list. This is just like a bunch of ones that I thought you might want to know about. OnLevelWasLoaded is a function that happens when a new scene is loaded. It's often used for stuff that you want to do when you switch from one scene to another in the same game. Really could be useful on Rubies because you have a scene switch going on. On-application pause is typically for pause menu setups and things like that. I don't know if I would just say a pause menu by itself would be a good idea for the final projects. That probably wouldn't be enough to be a significant mechanic. A pause menu where you can do a thing inside of the pause menu, like you pause and then you can toggle on time attack, that would be enough. So, and I think one of my suggestions for time attack on the final project is if you want to do a time attack mode, it should be something the player can turn on and off, not something that's constantly on. A constantly on one is 3.5 points, and a like always on, or a toggleable one is 5 points. So you could use on-application pause to set up like a really simple pause menu that says something like, I don't know, press P to return to normal gameplay, press T to go to time attack mode, or something like that. That could be a setup that you could use on-application pause for. I don't know if I would do that for a time attack mode, but I could see plenty of other things where that would make sense, like a super shot or something that you fill up a bar and then you can use this like extra powerful, I don't know, a thing that shoots a cog in every direction, something like that. I think definitely like a charge up mechanic could work good. I think for a time attack, it would feel weird to me. Like I wouldn't know why you're charging up a thing. Because in like most games, I feel like you like turn it on or whatever, you know. If you could come up with an explanation for why the mechanic needs to get charged up, I think it could work, but. On became visible or invisible are used basically for when an object becomes visible or invisible to any camera, and you can do really simple detection functionality with something like that. Like if Ruby is standing in this area, you set up a second camera, and if Ruby is standing inside of the area where that camera is, then do a thing. On GUI basically lets you do UI features. Doing a slider that the player can manipulate, drag back and forth, was actually something I used to show inside of my space shooter project. There was like a thing where I showed how to make like a light slider menu, but there are easy tutorials you can find on various places on that, like on YouTube and stuff. If you go onto YouTube, how to make a slider in Unity, you can probably find various ones that use that function. On destroy happens basically when an object is destroyed, and that's essentially what you would use it for, is you want to do things when an object gets destroyed. On application quit is used when you do, specifically when you use the quit function. So you know how we have the escape key to quit thing? If you have an on application quit line in there, it will do those things when you hit that button. So that's useful for cleanup at the end of the game, and like if you want to do a save functionality or something like that. Or if you want like a persistent high score, that's a thing if you do some hunting on, you could probably find pretty quickly. Persistent high score would probably be something that could work as a gameplay mechanic for the final. You would have to set up some sort of already like existing scoring system. Because the way Ruby's is set up right now, it's you collect X number of robots and win, right? Like a high score kind of wouldn't make sense, but if you set up something, I don't know, some other collectible she could grab, and then you do like a persistent thing on that collectible, that could be cool. Arrays. So I talked about this earlier before the video started when I was showing off the space shooter demo, but I'm going to walk through it again here just so it's part of the video so you can always refer back to it. Arrays work a lot like variables. So you give them a type and a name, like game object hazards, for example. The type is game object, the name of the variable is hazards. Realistically, we would probably want that H to be in lowercase, but actually in the default Unity tutorial, I think they have it uppercase, which is interesting. I'd be curious if that's like a specific thing in camel casing, but the brackets that we're seeing there after game object are indication that this isn't just a regular variable, it's an array instead of a regular variable. So when you have an array instead of a regular variable, what you can basically do is store multiple references of that particular type inside of the array. So in this particular example, we could have multiple game objects instead of hazards. Like hazards doesn't have to be one game object, it can be 4 different ones. That's what it is in Space Shooter. There's 3 asteroids and 1 alien. From there, once I've set up an array, then when I want to do stuff with that array, I typically reference, if I remember right, the term for it is the index of the item that I want from the array. Usually this is done by number. So usually what you have, if you have 4 items in the array, then like each of those items has a number associated with it that's its index, and you call that number to get that item. The way arrays are usually set up too is that they start from 0 just to be annoying like a lot of things in programming. So the first thing in the array is 0, the second thing in the array is 1, the third thing in the array is 2. So if I'm looking for the second item in my array, I would call for slot 1. Like if what I want is item 2, the second thing in the list, then in my code I would write like get the one that's in slot 1. So if I want the first thing, I would write get the thing that's in slot 0. The other thing I showed from Space Shooter earlier is coroutines, and I'm going to show you the code I was showing earlier. It just doesn't show as well on a PowerPoint slide, unfortunately, so I think if you're watching the video at home, what I would probably do is go into the Space Shooter project and pull the code up in VS Code so you can look at a much more readable version of it. But what coroutines are for is essentially the problem of functions always in the default setup running within a single frame. So like the way it normally works in Unity, the way most functions happen is that they happen frame by frame, right? But like, what if I want to do something over multiple frames? I don't want it to happen in one frame. I want it to slowly turn invisible, for example, which is, that would not work in one frame. What you would do is use a coroutine, which is coroutines are basically functions that can pause themselves, give control back to Unity, then pick back up where they left off and continue doing what they were doing. To make one, you make a function with the return type of IEnumerator. So like in this example, IEnumerator fade. Fade is the name of the coroutine. IEnumerator indicates that it is a coroutine. Then we have a lot of code inside of that that makes the thing turn invisible slowly over time. Typically, when you write coroutines, you have yield return lines at different places inside of the coroutine that indicate this is where I want you to stop. And then usually on the yield return line, you have to indicate something else too, like what the condition is. Often it's going to be a special coroutine related function like wait for seconds, that is wait for X number of seconds. And that's the example that I give here. The typical functionality is that, okay, so you use the start coroutine function to launch your coroutines. You have to use another function to start the function. And then typically the way they are going to behave is that they begin on the next frame update, but when they see wait for seconds, they pause based on what you've told it to do. So the one I showed earlier before the video started is this one, which comes from the Space Shooter project, and it's a coroutine called Spawn Waves. What it does is spawns waves of enemies. So it's used in a Space Shooter, again, for context, is like a Galaga-style game. So you're in a ship, you can shoot projectiles, there are asteroids and aliens coming down the screen at you from the top of the screen, basically. And what this coroutine does, I'm not going to walk through every single line of code now because we did that earlier, and again, it also just is hard to see on a PowerPoint slide. But what essentially this coroutine does is starts by pausing for a second, then it has a while loop and a for loop that spawns waves of enemies. So waves of enemies are getting instantiated, more or less. And then at the very end of that for loop, it has a example of one of those yield return new wait for seconds things I was talking about, where you're telling the coroutine to pause. It pauses for, I want to say it's 1 to 2 seconds. There's a line after that that looks very similar, yield return new, but this is telling it to pause between waves. So the first one we just saw is pausing between spawns of enemies. The second one is pausing between waves of enemies. And then the very last thing in this coroutine is a if statement that checks to see if the game is over or not, and if the game is over, it stops the coroutine so enemies stop spawning. That's more or less what's going on here. But it's a good example of the kind of thing you could do with a coroutine, and that you probably would need to use a coroutine for if you were trying to accomplish spawning waves of enemies in your Ruby final project, for example. What I would probably say is like coroutine is going to be the thing to look at. Like that's probably how you're going to get here. And what I said earlier during the part before we were on the lecture video where I was showing the game off is I explained that with some modification you could probably use this to spawn waves of enemies in Ruby. The biggest problem you would probably be faced with is this is set to randomly spawn enemies at the top of the screen and make them run downward. And you probably wouldn't want that. That would be weird in Ruby, so you would need to figure out some way to modify where it spawns. But most of the rest of this would work pretty well. Oh, I guess you'd have to figure out where you want to put this. I would probably recommend if you were doing it in Ruby's. Realistically, you would probably just need a whole new script, like a spawn wave script or something like that, where you would set this stuff up. Execution order. So what you probably have noticed with a lot of the stuff I talked about up to this point is a lot of these built-in functions and coroutines and all these other things are basically used to spawn things, do things at certain times. And so a lot of times, what we do in game design and what a lot of these built-in Unity methods are for and things like that is set up things for controlling when something happens. That's often as important as what it's going to do. Is when is it going to do it, basically. And what order is it being executed in your code. So there's a full overview of this in the Unity documentation. Going through it all in class today would take a very long time. I'll pull up the page just so you can get a idea of what it looks like, but it's pretty lengthy, but it's giving a huge breakdown of like, in general, what order things are flowing in. So we've seen one of these flowcharts before, right? Like I've shown you a basic version of one of these flowcharts. I think it was when I was giving examples of like how if statements work and how code works in general. But this is obviously a much more complicated one because it's showing you like literally everything they could possibly think of that's in Unity. So like, it starts with awake. So literally the first thing in the flowchart, like we talked about, was awake. Then on enable, then reset, then start, then fixed update. So it's showing you exactly what order it does stuff in. So that can be really useful sometimes for just troubleshooting your code and figuring out why things are doing what they're doing. Like if you're asking yourself, like, why isn't this happening when I want it to? It's probably related to execution order, and it's because Unity has a defined order that things happen in, and you're telling it to do a certain thing that it, is in a different part of the execution order, basically. I'd also just say this is a general thing that a lot of people struggle with when they're learning to code. I saw a lot of people still struggling with this on Challenge 3 and like office hours and stuff that we were doing appointments for, where I could tell the thing people weren't thinking through was just like the order of operations in their code, like when things were happening and in what order they were happening in. So really commonly, for example, is stuff like when you're doing the cogs UI, a lot of times people will do their like UI to string function before they set the value of cogs, and then they're like, why is cogs 0 when the game starts, and then when I hit C to throw a cog, it suddenly updates and shows me 3 cogs. It's because like cogs is 0 when you told it to put it on the UI. You told it to put it on the UI while cogs was still 0. You haven't set cogs to 3 yet. So be aware this is a very similar idea. But this is on like a function level versus a like line of code level. This is like when does it do functions, basically. Let's see, getting components. We've talked some about this too, but just as kind of a reminder, because we've seen these functions a lot, and this is going to probably be a key piece of doing a lot of like new gameplay mechanics for the final project, is interacting with the get component system. So in general, if what you are trying to do is script to a component on a game object, you want to do a thing in your code that is going to change a component that's attached to a game object, like a rigid body, particle system, audio source. Actually, with audio sources, weirdly, you don't have to give the component. I'm not sure why, but with like almost everything else you do. I think you can use get component on the audio source. I'm pretty sure it works, but for some reason you just don't have to. But generally speaking, this works for almost any component in Unity. Generally speaking, how do you do that? You declare a variable of the appropriate type, which is usually going to be just the name of the component is the name of the type. So rigid body is the name of rigid bodies. Animator is the name of animators. If I remember right, camera is the name of cameras. So like, it's almost always, I mean, you can look it up in the Unity documentation. So remember, like, if it's not working or you're like, why isn't this helping? Go look up in the documentation. It's maybe just like a syntax thing. Like it uses a different name than what you're thinking it would be. Like for example, this, if you tried to capitalize B here, private rigid body capital B RB, it would probably throw an error and be like, that doesn't work. So declare the variable, use the get component method to set the variable to the component you want. So RB equals get component rigid body, or anim equals get component animator, et cetera. Then do stuff to the components, which the way you typically access the various properties on the component is variable name dot name of the property. So in this example, it's rb.addForce. AddForce isn't technically a property that's written on the rigid body, but it's a thing you're allowed to do to rigid bodies, is addForce to them. But like, you can sometimes list the actual name of the component. A great example of this is text UI elements, where you do new text.text. You're literally accessing the thing that says text in the inspector. And then you set the text to whatever you want to set it, et cetera. And remember that scripts are components too. So get component can be used to get scripts. That's something you did a bunch of in Unity. Remember, there's a whole bunch of ways you can get scripts. I'm a big fan of using the tag functionality to do it rather than a lot of what they do in Ruby's, because a lot of the way they set it up in Ruby's is situations where it's used in one specific method, and if you try to use it in a different method, it will fail because it's only in that method. I'm a big fan of the tag system for that instead. And actually, Space Shooter is where I learned the tag system. That was another cool thing from that old tutorial. On trigger versus on collision, a big thing to know about this that I think I've hinted at a few times before, but I don't think it was ever on a PowerPoint slide, is that there's a slight difference in their functionality that can seem really small, but can sometimes be incredibly important to how a mechanic works or which one that you need to use with a particular mechanic. So on trigger, the on trigger ones, on trigger enter, on trigger stay, on trigger exit, et cetera, occur when a collider makes contact with the trigger and does one of those things. Enters it, stays on it, exits it, whatever. One of them has to have a rigid body, and one of them has to have a trigger, or it's not going to work. So, collision events are when you make contact with another collider, right? And at least one of them has to have a rigid body. So you still can't get anything to work unless at least one of them has a rigid body on it. The big critical difference is when an on collision happens, they actually pass the information directly about those collisions to a class called collision. That class holds information about what happened, like where did it happen, how fast were things going, et cetera. And so that requires processing power. And so from a gameplay performance perspective, if you have the option of on trigger for whatever the thing is you're trying to do, if that will work for whatever the thing is, like you don't need to store any information about the collision, on trigger tends to be the better way to do it, because that means it's going to be more performance, better on a performance perspective. If you do need to store that information, though, you have to use on collision, because if you don't, the trigger version doesn't store any information, and it won't know anything about the collisions involved. I think the example I've used for this before when we talked about it in class is like, say you wanted to make a jump pad in a platformer, like a specific place where you can jump and bounce really high or something like that. You would have to probably use on collision for that, because you would probably want it to do things like look at how fast the player was moving when they hit the jump pad and then throw them back off the jump pad at a velocity based on that. And on trigger would not be able to do that because it wouldn't store any information about how fast the player is going. So obviously you would have to use on collision in that kind of situation. But we've seen both of them. We've used both of them in various projects. And so when you're making new mechanics, probably a good thing to start with is if it's going to be a collision-oriented mechanic, think about which of these two is going to be the one you want to use. Like, should it be set up as a trigger situation or a collision situation? Math functions. So here's a bunch of random, there's a bunch of other ones too. A bunch of random math functions that you can just use to do different math stuff. So like, you're doing things that involve numbers and you want to have control over like what those numbers are going to do. Here's a whole bunch of things you can use it for. Clamp, you saw that in Ruby's. It also gets used in the Space Shooter, actually. So if you want to know how that game kept the player from flying off the screen, because you can't fly off the screen in that game. You can't, like, if you hold all the way to the left, you won't be able to move any farther. It uses a clamp on the player's vector movement, and so it looks at where the player is on the map, and it clamps where they're allowed to move between two numbers. It's used in Ruby's for health. It's for making sure health can't go above a maximum number or a minimum number. The minimum 0, the maximum is whatever you set it to. Lerp functions, we've seen a bunch of lerping stuff in the past, and they are for doing different kinds of lerps. If you want to know what the angle and unclamped ones are, angle lets you do angular lerps, so as opposed to doing a straight line lerp, you can do lerps that like do this or whatever, like can angle. And lerp unclamped lets you do lerps where t is higher than 1. The typical setup for a lerp is always that t is between 0 and 1. If for whatever reason you want it to be allowed to be higher than 1, then you can use lerp unclamped for that. And it will let you set t to a different number. MathF move towards basically moves a numerical value toward a target. So you define a target and a value that you want it to move at, and then it moves toward that target. Somebody was asking earlier about the player chasing thing. A lot of MathF move towards is one of the ways you can accomplish stuff like that. MathF ping pong we've seen before. It ping pongs a number between 0 and whatever top end you pick, basically. MathF repeat loops a value so that it's never smaller than 0 and never bigger than a given length. So instead of getting a back and forth ping pong, you could use that for like a platform that moves to a certain point and then like falls off a ledge and then spawns again, moves to a certain point, falls off a ledge. Or all sorts of other things, obviously. But there's some random functions that are used for just producing random values. Probably by far the most commonly used one is going to be random.range. Random.range produces a random floating point number between a given min and max. So when you write random.range, you define, I think the order is minimum and maximum. I think that's what you do. You like give it the min first and the max second. That is how, that was what Rubies was using to spawn random enemies when it was doing its, or not Rubies, the space shooter was using to spawn random enemies when it's spawning waves. So, but there's other ones. Random inside unit circle, inside unit sphere, on unit sphere give you a random point in space. For Rubies, inside unit circle would probably be the most useful one because it's for like 2D stuff that's going to produce a circle. The sphere probably wouldn't be as useful. Random rotation does random rotation. This is how Space Shooter did its rotating asteroids. There's a part in that tutorial where they talk about, hey, let's make our asteroids rotate, but there's a problem. If we just set them all to the same rotation, it's going to be really obvious to the player. Like they will instantly be able to tell that they all have the exact same rotation. So you use like a function to randomly rotate them. And yeah, random.color HSV generates random colors. You can do really interesting stuff like that, like generating enemies that have random colors, or even making them like randomly change color over time. I'd be worried about that being a little performance intense, but I had an example in a demo I used to do with Space Shooter that did used random color HSV, if I remember right, on lights to generate random lighting. And like it almost immediately would crash my computer. Like it would bring it down to a crawl almost instantly because of how insane that is in performance. But I think we talked about that a couple weeks ago. Lighting is very performance intensive. So the documentation stuff, I think, let me look at where we're at on time, because this is the thing I was referring to that's potentially quote unquote optional and that it's not on any quizzes or anything like that. We've got, I think, plenty of time to go through this, though, just looking at where we're at. So I guess, does anybody have any questions about, what I'll do is I'll watch the time, and if we're getting tight and I think I can't get to all the wrap-up stuff I want to talk about today, I'll like skip through things real quickly on the documentation. Does anybody have questions on any of these, like, I don't know, random code things? It's not really random. It's all things I know that will help on the final project, but it's a lot of just pieces of information, obviously. Yeah, so like random color HSV, that's, for example, if you threw that into update, it would randomly, every frame, literally, generate a random color. Right, yeah, I would be. Yeah, maybe if you were spawning enemies and you wanted the enemies to be able to spawn in with a random color inside of a wake, I would run that function, and then that way, like when the enemy spawns, it picks a random color, and then it doesn't do that again. It just, does it when it shows up. If you put it in an update, that's pretty much what it's going to do, because it's going to generate a random color every single frame. Oh yeah, you're going to get a wild random like rainbow effect, basically. You could. I would just check it for performance first to make sure it's not crashing your computer. That's why, like, I was warning. That's why I mentioned the lighting thing I used to do. I don't know if it would do it if you did it on a sprite. Like, it'd probably be not too bad, but if you did it on a light, yeah, it goes crazy. Like, I could get out my Alienware computer and do the demo on my Alienware, and it would still lag out my Alienware. So, like, it was pretty cool. It was cool. It looks really awesome, but yeah, you probably could not play the game while you were doing that. Any more questions about any of these ones or any of the previous ones too? Like I can answer questions about like on collision, stay 2D or whatever. Any of the other ones. Yeah, that would be my worry would be if you just like, if for example I used random inside unit circle to tell my enemies to randomly pick a point inside of a circle and then run toward it, you know what I mean? My worry is if it picks a spot that it can't get to or something like that, then you could have problems. But well, it would probably just immediately get another random number and just go somewhere else. But it depends on how you write this, right? Like if I just put that in update, it's going to constantly, every frame, it's going to pick a random point and try to run toward that point. So. Right. Yeah, I mean, one thing I would probably consider if I was going to do random movement with something like a random inside unit circle is probably doing a coroutine or something that controls the movement as opposed to just putting in an update. Because with update, if you're literally doing it every frame, it might just not work well. But I would set up like a coroutine that does it. Like a coroutine that tells it, pick a random point, walk to that point. When you get to that point, then pick a new random point and do it again. You know, that's probably how I would set it up. Yeah, a lot of these actually. A lot of random functions, the coroutine thing is really useful with them because you probably don't want them happening just like constantly. You want to control like when they happen. Random rotation is one you can throw into update. That works just fine. Any other questions like that? Okay, so yeah, let me look at time. 2:40, yeah, no, I think we're great. So I'm going to talk briefly about some of the main forms of game documentation. Those of you who are in game design have probably heard about concept documents, ASGs, and GDDs. Those are three that we've talked about in that class. The other ones I mentioned on these slides, the concept document, or no, the concept document, that's one you've heard of. The technical design guide, the schedule, and the writing style guide. Of those three, two of those three are ones I have you do in game production too. The only one I don't have people typically do on game production is that's on that list is the writing style guide. So these are going to be things you see in other game design classes, and I do go over all of these in my game production class with much more depth. Like there's basically a lecture on each one. And those of you in game design know there's like a chunk of lecture on each one of the ones that we do in that class too. So this is going to be more big picture, just kind of like generally what these things are. And then I'll talk a little bit about the documentation on the final project to make sure everybody's clear on kind of what you have to do for that. So. Just because that's something that sometimes people have questions about. I also quickly talk about rhetorical situations here. This is something that I kind of pull out of my like old English class lectures. And I'm not really going to go super deep on this. It's just that I think when you're learning about a new type of document, it can often be helpful to have this overview, like who is it for, why are you writing it, how should you write it, and like what should the format look like. And I'm going to use that as a way to talk about all these documents too. That's a way for me to be able to consistently go through them without going through each like template, because I'm not going to like do that. If you're in a class like game design, that's where I'll do those things. Like I'll actually go through, okay, what is all the pieces of a concept document or whatever. So I'm just going to use that to organize like basically what are the goals of each of these. So, and then I'll also use this to talk about the final project documentation. Like what are you trying to do on the final project in terms of this stuff. But yeah, purpose is why, audience is who, strategy is tone and style. So that's like what should your writing sound like and should you be formal. Design is like length and format, typically. So concept documents usually get described as a resume for a video game. That's typically the way I start my like lecture on that in my game design and production classes. Usually the goal of them is to provide important info about the game, like genre, story, basic gameplay, that is helpful for like selling and pitching the game. So if you're not familiar with like how typically things often work in the game design or in the game industry, often a publisher produces a pitch, which like the concept document is part of the pitch, or a developer produces one of those. Then they go to a publisher with that pitch and try to get the like funding and resources and stuff to get the game made. That's a very common model. So, and so you would write one of these concept documents as a way to convince people to make the game. And so that's your audience, essentially. It's like people who aren't designers. It often is used for the design team too, to like keep everybody having like a common vision. But like managers will see this, marketers will see this. This is the thing that you need to be able to show to people to kind of like pitch and sell the game. Style-wise, I often tell people don't go too formal. A bit of informality is okay, but I wouldn't go overboard on that either. You want to be clear and concise, and you want to be trying to make the game feel exciting. That's typically the kind of like tone you're going for with your writing, is like you're trying to get somebody interested in it and like giving you funding and stuff. I usually tell people try to stay positive in these. Like if there's a flaw in your game, don't like lie about it, but like try to spin it in a positive way, right? Like see if you can put it in a positive light as opposed to like this thing just doesn't work or something. Let's see. Design-wise, usually it's a mixture of short paragraphs and bullet points. It usually starts with a feature list that's like a list of bullet points that is basically the same feature list you would see on a Steam page or something like that. And then after that, it's usually some sections that explain stuff about the game that are written as like short paragraphs, like 2 to 3 sentences maybe. Sometimes a little longer if they're talking about something in depth like the story. This is also the one I kind of tell people in my game design classes, like people who are going to go into production next semester. You write one of these for basically every game in production, so like it's, to me, one of the most important documents. And for some of these other documents, I don't have you write for every game in production class, but this one I do. The art style guide of the ASG is usually focused on the visual style of the game. It can talk about non-visual things like aesthetics and game feel and sound and stuff like that, but it's usually very oriented on visuals. The audience is usually the artists on the design team. Usually the way I kind of frame this is like, a video game needs to have a consistent art style, right? So like when we play a game, we expect, it to all have the same visual feel. But most video games these days are made, with like 20, 30, 40 artists on the team. So how do 40 people produce, a consistent visual style that looks like it wasn't 40 people who made it, it was one person who made it, you know what I mean? And that's what this document's there for. It's for making sure like everybody's on the same page about what the visual style of the game is supposed to be. So like in a photorealistic game, you don't have somebody start suddenly making a bunch of cartoonish stuff, because that doesn't make sense with the visual style that the game is going for. Or vice versa. If you're doing a cartoony game and somebody does something really photorealistic, you can point out like, hey, that's actually too realistic for what we're going for. That actually happened in my game production class last spring. They had like a cartoony art style and somebody made a really realistic looking, what is the name of it? It's like the cattail things that grow in swamps. And I was like, that actually looks like really what one looks like in real life. The problem is that's way too realistic for the game you're making. You're more cartoony than that, so you need to like tone it down. And that's like, this kind of document helps with that kind of stuff. Strategy, it's usually not too formal because there's usually not a ton of text. So typically in an art style guide, you don't want to have a lot of writing. Usually it's mostly visual communication and you want to avoid like tons of wordiness. So that's why I usually say not too formal in tone, because if I say formal, people get the idea in their heads of like lots of text. And typically these don't have that. And then design-wise, I give a like really, really common tip that I give in most of my classes is these I feel like are typically best done in a PowerPoint format. You can do them in Word. I find that typically ones in Word often come out weaker because Word's not as good at handling visuals as PowerPoint is. Word encourages you to write more text, which you shouldn't be doing. And lengthwise, it's hard to peg a length for these. A lot of times people will ask me how long should they be. It all depends on layout and stuff like that. Like there's a lot of things that go into visual organization that make it hard to like say it should be X number of pages. Technical design guides. This is one that if you're in game design you probably haven't heard of before because it's not something that makes a ton of sense for the games you're making. The technical design guide is usually for like the coders on the team, and it's information about technical considerations like hardware and software, what like game engine are we going to use, what packages are we going to use, what kind of file formats are we going to be using for all our audio, and image and our sprites. We don't want to have like a bunch of JPEGs and PNGs and like random file types. We want to pick one and stick with that so it's consistent. The audience is very heavily aimed at coders and probably not almost anybody else. So like it's very unlikely anybody other than the coders are going to be looking at this in most cases. The design team in general might be looking at it too, like artists and stuff, but probably the design team only. Strategy, these tend to be very formal. Stylistically, they should be clear. And I usually tell people in my production class Try to give examples whenever possible with these. Try not to just give a like text description, but try to actually put in the code that you're talking about. And it doesn't have to be all the code, because like putting in all the code would probably get too much. But give, like if you say something like all variables will use camel case, then give an example of what camel case is so you can be sure everybody on the team knows what that means. And then yeah, these usually get done in Word. Length, they can be exhaustive, so it depends on how big the game is, probably. I think in my production classes, they usually end up being around like 6 to 8-ish pages, I feel like is kind of like the number sticking out of my head. So, usually I do say though, like, shorter is better than longer in the sense that like, everything should be there that people would need, but like don't put in 5 examples of something just because you feel like it needs to be longer. 1 or 2 is enough. You want people to quickly find what they need too. So like if you make it too long, that could be a problem. The schedule, this is one we haven't done in game design, so if you're taking that class, you probably haven't heard of it, but we do it in production. The schedule is basically like a list of timelines, milestones, and roles for team members and stuff like that, like who has to have what done by when. So like when is the alpha due, when is the beta due, when do you have to have the art done for the alpha, when does the code need to be done for the beta, et cetera. The audience for the schedule is the design team, but like anyone involved in the making of the game may be touching the schedule. And often what a lot of times will happen is there are different versions of the schedule for different people. Like the managers have a different schedule that doesn't have all the individual like level art for level 3 done by X. Their schedule probably is just like, here's the alpha, here's when the beta is due, here's when the next thing is due. Whereas the design team probably has one that looks more like specific tasks. Strategy, it's usually formal. Stylistically, the language is probably short bullet points and other really small pieces of information. And design-wise, it depends on like your strategy because different people use different schedule strategies for like time management and project management. So there's things called Gantt charts, there are things called burn down plans, you can use an Excel spreadsheet. There are various programs called Trello, and I'm trying to remember another popular one other than Trello. Trello is real popular in my game production class. People tend to like that one a lot. So there's a bunch of ways you can format it. In my game production class, this is one of the most open-ended documents that people turn in. So I usually tell people, I need you to give me a schedule. What format you give me the schedule in is up to your team, like whatever your team has decided on. And then length, yeah, that depends on the format chosen and like who the audience is and all sorts of stuff like that. So. The writing style guide, this is the only one I don't have people do in production, just because teams are small enough that, and there's not so much documentation that you need to have a document about how to do all the other documentation. There's a decent amount of documentation in that class for sure, but I guess if you want just some general context about like why am I even talking about documentation, because you may not be familiar with this yet, we haven't done a lot of it in this class. Most of the classes in the future of the program, you can expect to be doing a lot of documentation of the games. So like in production, half of your grade is like the game you make, and the other half is like the stuff you write about the game, basically. And that's common in the actual field, too. So when you work for a company, don't be surprised that like you're doing a lot of documenting. But yeah, the writing style guide is basically a document about all the other documents. It's like, how are we gonna write these things, basically? The audience is anybody who's going to be doing documentation, so pretty much the whole team. Tone-wise, formal, because it's like laying out how the rules for other things are going to be written. Stylistically, clear, focus on examples whenever possible, really similar to the technical design guide. So an example of that would be something like, all documents will use gender-neutral language such as work hours instead of man hours, so that we don't like offend anybody. So that's a good example of the kind of thing that might be in a writing style guide. Typically gonna be done in Word. Lengthwise, they can be pretty exhaustive. Generally, like a technical design guide, keeping it short rather than trying to make it totally longer just for the sake of length isn't a good thing, because writers need to be able to quickly find what they want. So keep it as short as possible, also including everything that needs to be there, is basically the advice I would give for one of these. Game design documents, this is one that people in game design are familiar with, obviously. The class is called game design, so of course you're doing one of these. These tend to provide comprehensive information about the overall design of the game. In fact, there are some views of game design documents, like some people, the way they view them or the way they talk about them or use them in their company, is that all the stuff we previously talked about would be part of the game design document. Like all that other stuff would fall under the umbrella of this, plus everything that I'm about to mention to you. I personally like to separate it and say, let's think of those as separate things and not think of them as all part of the GDD, because to me that just makes the GDD this like giant scary thing. So, but what it does is basically, other than all that other stuff, if that is in it, it talks about the overall design of the game. I often describe these as being exactly what they sound like. They talk about the design of the game, that's why they're called a game design document. Audience, anyone who's going to be designing the game, so pretty much the whole design team, typically. Strategy, pretty formal. Stylistically, it's usually a mix of bullet points and paragraphs. I often tell people when we go through like templates for game design documents, like we talk about each section, it's like, I often tell people, use common sense for what you think the format of this section can be, and a lot of times that will work. Like, when you're going over the game's controls, would paragraphs or bullet points be better? That's a situation where bullet points is probably way better. Like, nobody wants to read a paragraph to figure out how to control the game. Just list out the controls. When you're talking about the game's story, bullet points probably aren't great. That's not a great way to tell a story. Like, we use paragraphs when we tell stories, so I would probably use paragraphs for that section. And so that's a lot of times. I will often go through the template in my classes and be like, here's exactly what I would suggest for this section, but like of those two options. But that's typically what you're going to see. Usually done in Word. They're typically the longest document. They often have tables of contents because of that. I often tell people once you get above 10 pages, table of contents is something that's worth considering. And there's usually lots of clearly organized sections and section headings and stuff so that you can quickly flip to the part of the game design document that you need when you're trying to find something. So for the final project, there's two things you need to do on this front. One of them is a README/mini GDD. And what that is a very short version of a GDD. I really think it's more of a README file, which is something I have people do in game production as well. And it's basically just like a short, I think you say 250 to 500 words, piece of writing that just like explains how your game meets the requirements for the final project. I think in last week's lecture video, the way I explained it is like you go through each of the sections, challenge 5, or challenge 3, video, audio, new gameplay mechanics, and you write a like 50-ish word paragraph for each one of those. So explaining either like, here's how I met those requirements, or here's I didn't, and I acknowledge that I didn't, like that kind of thing. The other piece of documentation is the gameplay demo video. So as a real quick rundown of the differences, and you want to make sure, like, look back at the final project view video from last week if you want a more detailed explanation. You get a little bit more time. I think I give you 2 minutes instead of 1. And on this one, I tell you, don't worry about talking about things you couldn't get done. Only focus on the things you could get done. Because I want you to be able to frame this as something you could put in a portfolio. Like if you want to show this off in a portfolio later, you don't have a video that talks about all the flaws in your game, right? Like here's all the things I didn't get done. The README file will tell me all the things you didn't get done. So like that's where you cover that stuff. But in the video, try to just talk about the good things, like here's the things I did do, so that you have something you can show off, basically. The most important thing, I went over this a lot in the video last week, is both of these are required. You get a 0 on the whole final project if you don't submit both. So like if you only do one or the other, or if, I think the way I put it last week was if there was massive problems with one of them, then you could get a 0. If there are significant problems, what you would get is a 0 for that category. Like each one is worth 2.5 points on the rubric, I think. And so like say you had a mini GDD that was like really, like tons of grammar errors and was like really badly written or something like that. That might get you a 0 for that section, but not the whole final. If you gave me a literally unreadable GDD, like it's impossible to understand or something, that could get you a 0 for the whole project. Or just not doing it, right? Like, so if you don't do it, that's a problem too. Similar things for the video. Like if the video just straight up, like there's no visuals whatsoever, you could do a 0 on the whole thing. Major problem in the video might just get you a 0 on the video itself. But make sure you pay attention to the documentation stuff. Definitely sucks to do a whole game and then not turn in a video and get a 0 for all the work that you did. And I think I went over this a lot last week. The final projects with 25% of your final grades are getting a 0 on it, like, very bad, obviously. It's pretty much impossible to pass. And I'm going to do my wrap-up stuff next. If I have a tiny bit of time afterwards, and once I've stopped the video, if people want me to go back to those slides and like quickly run through them or something like that, I can try to do that too. But does anyone have any questions about documentation? Because I think the next section is just stuff about the rest of class. Like what are we doing over the next couple weeks and stuff. I think the assignment is set up to accept .doc files, so I think you can actually directly submit it to the assignment. I think I mentioned on the assignment I would prefer if it's not in the zip folder, but if you need to put it in the zip folder for whatever reason, that's okay. Yeah. I like it not being in the zip folder because then I don't have to actually, I can read it inside of the web courses browser, and that makes it a little quicker to grade, basically. But if, you have a problem, it's not a big deal. You could attach it to a comment too. I would be cool with that if it's obvious that that's what you did. Yeah, exactly. So you basically go over the stuff you did. I think I talked about this last week in the video too. If you got a 5 on challenge 3, in the video it's okay to say I got a 5 on challenge 3 and not demonstrate the stuff from challenge 3. You can just say like, as shown in my previous video, I got a 5 on challenge 3. Refer to my previous video if you want to see that this meets all the requirements for that. You can do that. If you didn't get a 5, my recommendation is just don't say anything about your grade. Like, don't make a comment that you got a 5. That'll trigger me to know that you didn't get a 5 on the challenge. You know what I mean? But if you didn't get a 5, you need to show that it all works. So you need to demonstrate that like the challenge now does meet all the requirements. So you can only do the like skipping that if you got a 5. And that will like save you time so you can show more stuff in your video if you want to. One other thing I think that's come up before, because people have asked about this on the demo videos, is length. I am not as much of a stickler in this class about length as I am in other classes like game design. I typically will only dock you for a length thing if it really feels like you were being unnecessary about it. I will say when it's extremely over, so like if I got a 4-minute video for the final project and I gave you 2 minutes, that's like double the length, I would probably take up points just because you're at like literally twice the required length. But it is okay to do stuff like editing the video. So like I've seen people before like edit it so that they skip to certain sections. That's totally cool. You can do stuff like that if you want to. Okay, so final wrap-up stuff. Next week we have Thanksgiving, so we don't meet for class. I think UCF offices are open, but I think is what they said on the website, but like classes are not happening. The week after Thanksgiving, so not next week, the week after, we won't actually physically meet either. So we're not going to actually physically meet again until final exam day, and I'll talk about that in a second. But what I decided to do for the week after Thanksgiving is, opposed to doing a review lecture, which is what I usually do that day, it's very similar to the midterm day, where I'm like, hey, let's go over a bunch of stuff we've seen and just review it. I felt like instead what would be more helpful would just be to offer more office hours and for them to only be for this class, so that nobody from my other classes can come to them. That way I have like a bunch of extra time, basically, to help people with stuff. So what I'm going to do basically the week after Thanksgiving is I have a 1:30 to 3:20 class for computers and medium, and then I have a 3:30 to 5:20. So from 1:30 to 5:20, I'm going to hold office hours for just computers and medium, and I'm going to prioritize based on like which class you're in. So when you message me for these ones, tell me if you're in 1:30 to 3:20 or 3:30 to 5:20, right? And the way I'll do it is basically this. If it's, say, 2 o'clock, nobody is in line from the 3:30 to 5:20 class, and you were in the 3:30 to 5:20 class, then I would be willing to help you. Or I'm sorry, the other way around. Nobody's in line from 1:30 to 3:20. But like, if somebody shows up that's their class time, then I'm going to prioritize helping them first, because like that's when they would normally be in class. That's just because like this is you normally have this time available, right? So I want to like try to prioritize based on that. But don't be afraid to come to the other one. So like right now, this is the 1:30 class. Don't be afraid to come at 4. Just be aware that if there are people from the 3:30 class who need help at 4, I'm going to help them first, because like that's when they're supposed to be having class. But yeah, that should give me more time to help people with office hours and mechanics and stuff like that is to basically, and then I'm also gonna do other office hours that week, so I'm gonna give you my schedule for final exam week first, and then on the next couple slides I have like, what is my schedule for Thanksgiving week, what is my schedule for the next week after that, so I'll go over both of those. But I gotta talk a little bit about final exam day first. So the final exam day for this class is December 8th, Wednesday. For this particular class that I'm talking on right now, the 1:30 class, that would be 1 to 3:50. For the 3:30 to 5:20 class, if you're watching this video, your time is 4 to 6:50 on Wednesday. That's when the waiter class does the final. But we don't have a final exam in this class, so you're not coming in here to take a test or like any sort of paper exam or anything like that. The final project is the last assignment for the class. There's nothing due after that, and right now it's due on December 5th. What we will do during the final exam period, because we have to hold a learning activity during the final exam period, so that's what I'm going to be here to do, is to hold that learning activity. What that learning activity will be is anyone who wants to show off their final project, or any other game, honestly, if you want to show something other than the final, I'm cool with that too, is welcome to come and show off the game in the room, basically. There are no points associated with it in any way. So there's no extra credit for doing it. You get the extra credit for just posting on those discussion boards, right? So you don't have to actually show your game to get points. I do that because otherwise it wouldn't be fair to the people who can't come to campus. So yeah, you're not getting any extra credit points for that. You're not getting any regular points for that. You won't lose any points for not doing it, like not participating in it. So it's like a if you want to type of thing. But I have to hold a learning activity during that day, so that's what the learning activity will be that day. And the biggest thing I'm trying to stress to people is if you ask me if it's required, the answer is yes, because we are required to hold a learning activity that day. So I'm going to be here doing that. And if your question via email or whatever is it required, the answer is yes. That's how I'll respond to those emails. I'll tell you, like, hey, go back and watch the lecture where I talked about it. But if you don't show a game that day, you're not losing points. If you do show a game that day, you're not getting points. So keep that in mind too. I guess the only other thing that can sometimes come up here, I don't think they've emailed me about this, but occasionally I'll get an email about this. They occasionally have to double book finals. So there are situations where sometimes like another final will be at the same time and you're in my class and technically, you're scheduled for both finals. And what they'll usually do in those situations is say, reach out to your professors and ask for a accommodation. Unfortunately, I can't make an accommodation for showing your game in the room because I can't get the class together again to come back and see your game on a later date or something. That's just not possible. So the other professor would need to make an accommodation if you're absolutely you have to be here. So you would need to arrange that with them. But just be aware you're not going to lose any points or get any points on that day either. So. Yes, because UCF policy says attendance is required that day. So you are not losing any points for not attending, and you're not getting any points for attending. But yeah, if the question is, do I have to come? The answer is yes. That's what UCF says. So if you can read between the lines, awesome. But that is the official answer. And if you ask, via email, that's the official answer. So, but that is the official answer. So. We have to do this. So I'm not allowed to make it virtual either. I've already asked that question. So could I make that virtual? The answer was no. Other final stuff. So my office hours will be different over the next couple weeks, probably just because of finals and things like that. Usually there are not any office hours during finals week. I can do appointments that week, but because of final stuff, because I have to come here physically for these and be in this room doing those, I can't do the same. It's not easy to do office hours. So I can do appointments. We can set up appointments. I would probably want to set them up on Tuesday or Thursday because I have to be here Monday, Wednesday, Friday during finals week. So more likely than not, it definitely could not be during any of the times on those slides because I have to be in here. So just keep an eye on the announcements. I'll probably post all the updates to the announcements. I've already decided what they're going to be, and I'm going to have them on these slides too, so you can always look at these slides. But there'll be an announcement with all this stuff just as a reminder because they're not going to be the same as what's on the syllabus. So next week, 1:30 to 3:30 and 12 to 2. 1:30 to 3:30 is Monday, 12 to 2 is Tuesday. And keep an eye on the announcements for any other changes to that. There's a slim chance if I can work it in, I might try to do like an hour on Wednesday or something. I'm not sure if I'm allowed to, if like that's a holiday and I'm not supposed to do it, but I might try to squeeze an extra hour in if I have time. But otherwise, yeah, next week I would definitely plan to come in Monday or Tuesday if you want to see me. Don't bank on there being anything Wednesday, and like Thursday, Friday, I can't do any for sure because those are holidays. Finals week, or not finals week, the week before finals, so the week of 11/28. Here's what they will be. 1:30 to 3:30 on Monday, 12 to 2 on Tuesday, 12 to 2 on Thursday, and then on Wednesday, that's where I'm doing those only computer is a medium office hours. So if you're in game design, don't try to come for any stuff during that time. That's going to be set aside exclusively for this class. The only way I might help you is if like there's literally nobody in line for this class whatsoever, but like I'm otherwise like reserving that pretty much exclusively for computer as a medium, just to be sure like I have a ton of extra time. And then yeah, just be aware, Thursday's the last day. Friday that week, I have like back-to-back presentations all day for game design and then meetings, so I can't actually do any on Friday that week. So like Thursday, what is that, like the December 1st or 2nd or something, is like the last day I'll basically have office hours before the final project is due. If I do, for whatever reason, move it back because like I can't get challenged to be graded fast enough, which I don't think is going to happen, just be aware, like say I pushed it back to Monday because I didn't get you the feedback till Monday, I wouldn't be able to also do office hours on Monday, so I wouldn't have any time to actually help people with stuff, and that's why I'm trying not to actually have it due any later than the 5th, because it seems weird to me to have it due and then not be able to help you on it. So, the last thing I warn you about in particular for this class, because this has been a consistent thing like all semester, is this block of office hours in particular, the 12 to 2 on Thursday, the very, very last one that I have before the assignment is due. My recommendation would be don't try to come to those unless you absolutely have to, because the last office hours before every assignment has tended to be completely swamped and I usually can't help everybody. So be aware we can troubleshoot stuff via email. So like after that point, we could try to do stuff via email over the weekend, but like I've been saying all semester, there's a lot of times where email, I'll like give you a bunch of suggestions, but it would just be so much easier if we were actually on a call. The problem is like, a lot of times what happens before a major assignment is due is so many people come to office hours I can't actually get to everybody during that time frame. A really good example of this was last Friday, like before the challenge was due. I think I have the number, hold on. Just because I don't want to just say I get really busy, I want to give you an exact example of it. Last Friday I had 9 people waiting for help when I started my 30 minutes of office hours, and like I definitely couldn't help everybody because I can't do 9 calls in 30 minutes, So I moved my office hours the week before the project to bigger blocks to try to solve that problem. That's also why I did the Wednesday computer as a medium only office hours things. So hopefully that will alleviate a lot of that issue. I would still say if you come on Thursday, the very last day I have office hours, expect that it's going to be swamped. Like I'm predicting that's what's going to happen. Like I'm just kind of preparing for it. So I might be able to do some stuff after 2, but that week I have game design presentations too, and if like I have people Thursday afternoon, then that may be a thing. I might have people Thursday afternoon, so I can't guarantee that like after that 2 o'clock time frame that I'll have any more time for office hours. If I can squeeze some in, I'll try. But yeah, I can't and I know for sure Friday's out. Like I absolutely know that Friday is going to be meetings basically from 9 a.m. for the rest of the day, so I know for sure I won't have time. So just, yeah, we can also set up appointments for non-office hours time. So be aware that's another thing a couple people said. The problem is that like I can only come on Friday. Like that's the only day I actually have free that is when that lines up with office hours. So be aware as long as we set it up in advance, like I'm cool with that too. But we need to set it up in advance. I can tell you for sure, for example, already that like that Friday is out. So I usually tell people like give me like 48 hours so we can find a time that works for both of us and then we can do that. But one thing I will say is on the flip side of that, if you want to make sure you have plenty of time to solve a problem, like Because what'll sometimes happen on a busy day too is I may tell you like 10 or 15 minutes into the call, hey, there's a bunch of other people in line and we have to wrap this up so I can like try to assist a few more people. The days where that tends to not happen are Monday, Tuesday. Like yesterday, I was on a call with somebody for 45 minutes because like no one else was online and we could just like sit there and work on like everything. So try to come earlier in the week if that's a possibility, and that usually will mean that you can get way more time. You know what I mean? Than like on a last minute day. Like that Thursday, unless things don't go how I'm expecting, I will probably do something like a, hey, 10 to 15 minutes tops per call because I've got like 10 other people in line. I have to get to them too. So just, yeah, like keep an eye out on that. Try to start. That's why we've gone over all this stuff super early. If you come to office hours like tomorrow, I highly doubt you're going to be competing with like anybody really. So we should have tons of time to work on stuff. But like, if you wait till December 1st or whatever, that's probably going to be a day where I have like 10 plus people all wanting to do calls. And I'll try to, like, I'll do my best, but again, I can't do 10 calls simultaneously. That's not possible, so I have to do what I always do, is just like go through them in order, like as best as I can. Yeah, tomorrow is 12 to 1:45. This is the last week of normal office hours, I guess. That's maybe a good way to think about it. Like the ones I have on the syllabus, this will be the last week I do it like that, and then for the next 2 weeks after that, it's these ones. Hold on, I can go back to them. And you'll see announcements about these soon. There's next week with maybe like an hour on Wednesday if I can make it work. And then there's the finals week one. Or not the finals week, the week before finals. Finals week, I won't do anything other than appointments. So. I think that's everything that I'd wanted to get through today. Does anybody have any questions about any of that stuff? I guess it's 3:15, so we won't have time to go over anything else for the final, but I'm going to go ahead and stop the video.